In this video, we're going to look at a falling object, such as this ball falling. As the ball falls, the distance it travels every step, or every second, is greater than it was the one before. Now, if we were to plot the displacement versus time graph for the object falling, it would look like this. From the displacement versus time graph, we can figure out the velocity of the object. Now, the velocity is our change in displacement over our change in time. So we'll go ahead and pick 2 points on our graph, and we'll find the change in displacement here and our change in time. And we notice that this is the same equation as the slope of the line that passes between those 2 points. Now this will give us the average velocity between the 2 points. And if we're looking for the instantaneous velocity at a single point, we just go ahead and take this second point and bring it closer and closer to the point that we're looking for. Now, as we get closer and closer to just being a single point, we can realize that this is the very definition of a derivative, because the derivative is the rate of change that's happening at a single point. So the derivative of the displacement versus time graph would give us the velocity versus time graph, which would look something like this. Now, to find how the object is accelerating, we can just take the derivative of the velocity versus time curve, and that'll give us our acceleration versus time curve, which would look like this. We can also use this to determine our functions associated with this graph. So if we take the derivative of the displacement equation, we get our velocity equation. And if we want to find our acceleration equation, we can take the derivative of our velocity equation.